would like to present on the safe compounding ingredients for silica reinforced natural rubber composite. And before moving into the research work, that I will show some example of our work on those compounding ingredients with focus on the utilization in natural rubber compound reinforced by silica. Let me introduce you about Prince of Songkla University. As the chairman mentioned, that we are situated in Thailand, and Prince of Songkla University have 5 campuses distributed in the southern part of Thailand, and I'm from Pattani campus, which is quite close to Malaysia border. And we have our main campus in Hat Yai. The university was established in 1967, and in terms of figure now, we have about 35,000 students and 2,500 of academic staff. And you can see this is from Pattani campus, a very nice and beautiful campus and the oldest one. And we have 8 faculty here where I work at the Faculty of Science and Technology. Faculty of Science and Technology established in 1985. As you can see from the Google Earth here, we are nicely located close to Pattani Bay. So we are here close to Pacific Ocean, and then we can see a beautiful sunset from the rooftop of our tall building here. I'm now taking a role of Dean of the faculty, and we have just about less than 800 students. And rubber is one of our research flagships here, as you can see. Our faculty have a multidisciplinary research covering from rubber, agriculture, aquaculture, food science, natural resource, and energy. And of course, rubber technology is one of our strong points here. Okay, let's move back to the topic of my talk today. I will start giving introduction about research and development for tires, and then introduce tire labeling. Some of you may already know, but there's some new development here. And then move to low rolling resistant tire by Silica-silane technology. And then also to comply with my title of the talk today, I will tell you about the safe rubber compounding ingredients with focus on processed oil and alternative for diphenylguanidine or DPG. We are now moving toward more green and sustainable tire industry. So if we look at R&D for tire at the moment, we need more energy efficient and less CO2 emission tire. That means we are searching for lower rolling resistant tire. And now we discuss a lot about tire wear particles. So that means if we want to reduce the tire wear particle, we need a tire with better abrasion resistance, or it should have better durability. In terms of the safety, we need to look carefully on those ingredients that we added into the compound. Can we use the safer one? And shall we rely more on sustainable supply instead of petroleum-based raw material? So there are so many aspects to drive forward toward this green and sustainability in this industry. And importantly, nowadays we are talking about EV or electrical vehicles. There are some changes, requirement for the tires as well. By having battery to provide power instead of the combustion engine, that means the weight of the car will be also heavier and introduce higher torque. So if we are looking for tire for this EV passenger car or different type of vehicle, we are looking for even lower lowering resistant tire because we need to drive for more distance before stopping to charge your battery. Because of the higher weight of vehicle, that means we will have longer braking distance. So we need to look carefully on the weight grip, and we should have better weight grip. And also, if possible, we should have also higher wear resistance. So if we look at this magic triangle, we need to extend to all three angles. I mean, we need lower rolling resistance, better weight grip, and higher wear resistance. And moreover, because of no combustion engine anymore, that means we can hear external noise more compared with the conventional car. So we are also need to talk about the low noise tire. So there will be quite a challenging time ahead for tire industry to meet all kind of this requirement. And for those who are familiar with tire labeling already, you may familiar with the EU label on the left side of this slide, which was issued in 2009 and applicable since 2012. But lately this year, EU introduced a new labeling system, changing classes given to rolling resistance and weight grip. So from 7 classes, was reduced to 5 classes, and there will be more detail on the noise level. Also, there will be some additional symbol for snow grip and white and ice grip. Also, EU now discuss about the possibility to include wear resistance into this tire labeling, because as I mentioned earlier about the tire wear particles, and we want to reduce that because it's also contaminate the environment. However, we cannot do it now because the test method for the durability or wear resistance for tire are still under discussion and under development. Once we have this test method ready, I'm sure that the labeling system will be another kind of property introduced into that. And they plan also to extend to retread tire. And for this wear resistant, actually EU announced that they target for 2025. So there will be quite indeed moving into this area. And for labeling system, for the rest of the world, they have been introduced like in Japan, in South Korea, in Brazil, in China, and recently also in Thailand, we have also introduced this type labeling by using a label from EU as a model. So mainly it covers rolling resistant, wet grip, and noise. When we talk about the low rolling resistant tires, so we need to move from carbon black filler to silica-silane technology. And on silica surface, we have numerous silanone groups that bring some difficulties from mixing. And this silanone group, there are 3 different forms of them. We have isolated, vicinal, and germinal silanone group, which are having different reactivity. So when we talk about reacting this silanone group with silane coupling agent, those different form of silanone group will also react at different octane. For coupling reaction between the silica and rubber, as you can see here, we have silane in the middle. By having silanization reaction that is driven during the mixing process, we will have the silane molecule attached or covalent bond to silica surface, leaving this polysulfide functional group to attach to polymer molecules during vulcanization. So the principle of low rolling resistant tire that we obtain from this silica-silane, it can be simply described by the effect of double network, because once we do vulcanization, we have cross-link. So we have chemical cross-linking, and we do coupling reaction. So you have also covalent bond between filler and rubber, and this double network lead to a lower hysteresis. That means we have less energy loss during dynamic deformation. And this silanization reaction efficiency is a key factor to success. So we are talking about two different steps that we need to look carefully when we use silica-silane in rubber compounds. The silanization during mixing and coupling during vulcanization. Why we study natural rubber? As you know, that Thailand is the biggest producer of natural rubber for many years, and it is sustainable resources because we can replant natural rubber in, and also EU declare natural rubber as a critical material for the second time in a row. So it is important and has a unique properties with this quite amazing. I mean, we have more than 99, or we'll say 98%, almost 100% of cis structure. So it is stereoregularity is very high, and we have strength-induced crystallization that give a property of natural rubber differ from other type of synthetic rubber. And natural rubber go to tire industry mainly, so it take about 65% in Thai, and the rest we go to different type of application. So when we use rubber, we need to also formulate the compound well in order to achieve the required properties. If you look at the rubber compounding ingredients in compound preparation, in addition to rubber or elastomer, you have many types of additives. And today I will talk about process oil and accelerator in case of diphenylguanidine. And actually, we can also look for some other kind of ingredients as well later on. So for rubber process oil, this highly aromatic oil has been banned for many years, especially in Thai industry, because of the presence of polycyclic aromatic hydrocarbon, or PAH. There are so many types of polycyclic aromatic in DAE, or highly aromatic oil, but so far 8 types of PAH have been classified as carcinogen, so that lead to a ban on this kind of material. But there are different kind of oil that you can use in replacement of DAE. The widely used replacement oil for DAE is TDAE. So we have treated distillate aromatic extract. We simply do the distillation to remove this PAH out of DAE. But you can also use naphthenic oil or mild extracted solvent. So there are alternatives from petroleum-based oil for this highly aromatic one. And by changing type of oil from DAE to TDAE or MES, please aware that because of different composition, if we can see from the different ratio of aromatic carbon, naphthenic carbon, and paraffinic carbon, they are different. And this different composition and of course structure, this oil have different glass transition temperature. So when we add this kind of oil into rubber compounds, we also expect that our dynamic mechanical properties of those compounds will be also affected. And if we simply look at proton NMR spectra of this three type of oil, you can see that DAE contains amount of aromatic proton and show a trace of a proton in polycyclic aromatics, and it's already removed when we have the TDAE and MES. What else can we use in addition to petroleum-based process oil? And actually, this is quite a hot topic, I would say, because now we are talking plant-based rubber process oil. And based on our investigation previously, we look at epoxidized palm oil and also amine modified epoxidized palm oil. There are some work on epoxidized soybean oil. So this kind of oil, if we look at the structure, it composed of tricrystalline with some unsaturation there. So this will allow us for chemical modification, like what we do here. We change this double bond into epoxy ring, and this epoxy ring can be opened easily. That allow us to do some further chemical modification, like here we attach amine on epoxidized oil. I show you some of the work that report on this plant-based rubber process oil. If we follow the work from Goodyear, we may see that there is a big project launched by Goodyear recently on soybean sustainability framework, and by replacing some part of their rubber process oil by this soybean oil, aiming, I don't remember exactly by which year, but they aim to use soybean instead of petroleum oil in the future. And there are two more examples here. Use of epoxidized soybean oil in silica fuel solution SSBR, and the study on soybean oil for thread rubber. And this work published in 2019 and 2020 last year. So this proves that they are demanding now, because people are working toward this kind of green compounds. Look at the example of the work that we did on palm oil. So we took palm oil that's available in the market and do simple chemistry, the epoxidation by having hydrogen peroxide and formic acid. Under mild condition, you can convert this unsaturation site to epoxy ring, and we can prove by having NMR spectroscopy. By varying reaction term, we obtain different mole percent of epoxy group, and this can characterize by also the titration technique. And we have 3 different levels of epoxy here. And we took one of the EPO and do some further modification by introducing phenylparaphenylene diamine or PPD here. So reaction was done at 100 degrees using zinc chloride as catalyst, and we obtained 2 different levels of PPD grafted on these oil molecules by having characterization by NMR. So it proves that we have done the reaction successfully. Then we use that modified oil into our rubber compound. Here we compare the modified palm oil with TDAE, and also we have the one without oil as the control. Mixing procedure follow this 2-step mixing. I show you some example of properties that we obtain by utilizing this modified oil. If you look at the kiln characteristic, comparing with TDAE, now we want to see whether this plant-based oil can replace TDAE. So based on this kiln curve, you can see that by using epoxidized palm oil, we can raise the cross-link density that is interpreted by the maximum kiln torque. So we increase the maximum kiln torque, especially for this case for EPO with about 3% more of epoxide. And we have higher kiln reaction rate by having this modified oil. So what happened there? I should mention that even we have silane coupling agent with silica, and we do silanization reaction during mixing, there will be only about 25% of silane group that can react with silane coupling agent, because once some group of silanone has reacted, it will be a kind of steric effect or steric hindrance that prevent the incoming of new silane coupling agent molecules. So if 25% reacted, that means we still have plenty of silanone group on silica surface, and this silanone group can still interfere with vulcanization. So in the presence of oil, the absorption of these molecules of oil can introduce hydrophobicity on the silica surface. So we can see that we have better kiln properties in the presence of this kind of oil. In terms of dynamic property, if we look at tan delta at 60 degrees, which has been used as indicator for tire rolling resistance, comparing with the one without oil and TDAE, by using this modified oil or even the palm oil, the original one, we see a reduction in tan delta, which means if we use this compound for tire tread, we expect to have a lower rolling resistance. Also, the tensile properties of those compounds, I can show you here that by having EPO with 2 and 3% more of epoxide, we end up with similar tensile strength of the property. So mechanical and dynamic property, we satisfy with the use of this modified oil. And if we modify further by having amine, then we take EPO also as a control, and we have two different of amine modified epoxidized palm oil. Also kiln characteristic is improved. We can see a higher maximum torque here, and this maximum torque can be related to cross-link density in the vulcanized set. So by having better kiln, we see a lower tan delta at 60 degrees by using this amine modified EPO. So for tire application in terms of dynamic mechanical property, by having modified palm oil, we can see a better elastic response without a loss on mechanical properties. So to summarize, for EPO and amine modifying EPO oil, by having this oil, the hydrophobicity is promoted, and then resulting in enhancement in processability, mechanical and dynamic properties. And we are confident that this kind of modified palm oil can be utilized in silica reinforced compound in replacement of petroleum base. And actually now I think many big oil producing company, they are also producing this kind of oil. Okay, let's move to another topic on DPT and its alternative. Why we interest in DPT? Because we are working on silica reinforced rubber. And for those who are familiar with silica-silane technology, DPT is an essential ingredient for these compounds. If we look at the roles of DPT here, DPT accelerates the vulcanization reaction because DPT itself is a secondary accelerator. It promotes the silanization reaction. And as I said, only about 25% of silanone group reacted. So we have plenty of free silanone group. So this DPT can help to deactivate those free silanone group as well. But the problem is once DPT is decomposed at high temperature, we have aniline, and aniline is a toxic substance. So can we have other additives in replacement for this? If we look at the rate of liberated aniline, we can see an increase of rate already at the temperature about 130 degrees Celsius, and increase remarkably at higher temperature. And this range of temperature is the discharge temperature for rubber compound mixing. So if we use DPT, you will have aniline. Let me show you about the influence of DPT on properties. As I mentioned, this is an important ingredient for silica compounds. There was a report many years ago showing the effect of DPT content on properties. So we can see an enhancement in kill property in the presence of DPT and improvement in pain effect. So we can see a lower pain effect here and higher chemically bound rubber when we increase the DPT content, and we can see a clear improvement in inside property. So based on this work and also the work on synthetic rubber, based on solution SBR and BR, we need about 2% by weight related to silica of DPT in this silica compound. So we took different kind of amines to investigate, having also aliphatic amine and cyclic amine having different molecular weight, and having DPT as the reference. Once we have the silanization reaction, we have byproduct of ethanol. So first of all, we study kinetic of those different amine on silanization reaction. And model compound study was based on a mixture of decane with silica and silane, and we have amine heated at 135, and then we follow this method or procedure, and we want to measure the concentration of ethanol. So we did that by using GC. So 1 molecule of TSPT releases 2 mole of ethanol. By using this equation, this primary silanization and secondary silanization, we can obtain the rate constant of those reactions. So if we see the concentration of ethanol per concentration of TSPT, by simply looking at this plot, we see already the effect of amine in the model compounds. By having amine, we have different concentration of ethanol generated from the reaction. And applying those relationship, we have a rate constant here. So we have much higher primary silanization reaction rate compared with the one without amine. And about among those different type of amine, different structure of amine effect on different rate. When we look at the compound, because we can see nice chemistry on model study, but we want to see whether it works in the real or practical compound. So we use those different amine type based on molar equivalent using this formulation following two mixing steps as I show here. I show you here a plot of storage modulus versus strength. This is a kind of pain effect study. So we see that different type of amine give similar behavior. We see pretty close of those storage modulus that change according to strength. Only DIC with two cyclic structure, this is bicyclic structure, give higher pain effect. Once it vulcanized, we have a clear lower tan delta compared with the compound without amine. And if we look at the mechanical properties in terms of tensile strength and elongation at break, if we see DPT here and other type of amine, you can reach a similar level of tensile strength by utilizing this octadecilamine, cyclohexylamine, and also the EC. So a kind of different amine can be used in replacement of DPT, that we can still obtain similar mechanical and also dynamic properties. We investigated different compound property before and after vulcanization, but I select some results to show you here, just to give an idea that if we don't want DPT in compound, you have something else to be chosen. What happened when we have this amine? When we have silica particles, we have bound rubber, a layer, and on silica surface we have silanone group. And as I mentioned, that when we have this amine, it can interact with free silanone group, so it changed in terms of hydrophobicity, and also this long aliphatic tail of amine. This also can entangle with rubber molecules, and that help to achieve a properties close to what we actually wanted. By comparing DPT and octadecilamine, here based on different property, we select octadecilamine as alternative, and we vary the quantity of octadecilamine in comparison with DPT in order to see whether we can see the optimized content. And based on various property and tan delta at 60 degrees is chosen as example here. We can see a drop in tan delta at 60 degrees, which we use to indicate for rolling resistance. We can have even lower tan delta compared with DPT. So if I summarize for this study, based on model compound study, linear aliphatic amine work better than cyclic aliphatic, so it gives higher rate constant of primary silanization reaction. And the use of octadecilamine provide the property of rubber close to the reference compound with DPT, and by having the optimum loading of octadecilamine, we can have even better mechanical properties and tan delta at 60 degrees compared to DPT. So what's next? Now we can overcome those process oil and alternative for DPT. We can use either safe petroleum-based process oil or the plant-based process oil. So we have choices. You can apply octadecilamine in replacement of diphenylguanidine. But there are some other ingredients that I show here. So if we want to have more safer. Safer and moving toward sustainability. I think we have something more to do in terms of tire industry. Like we can probably look at carbon black or even silane, which produce less ethanol, because ethanol also is a volatile product that we should also reduce, or we can look at different type of ingredients. Okay, I would like to thank this organization who support this work, and the work that I show here based on our collaboration with University of Twente in the Netherlands, with sponsorship from the Dutch Natural Rubber Foundation, also from Apollo Tire Global and the Netherlands. And thank you for your kind